you see two series here. Here you see one first series and this is the second series, and nth term of this series is here, and nth term of the second series is here. So in this question we have to find whether the given series are convergent or divergent, etc. So let us see. First we check the necessary condition, and for that we find LT n tends to infinity, and obviously it is 0. So this series may be divergent or convergent. And let us check for the other. The second series is the nth term of second series is Bn, and if you do the same, then we have this also equals to 0. So both the series, this series satisfies the necessary condition. So we have to use the test to know whether these are convergent or divergent. So for the first, and here for the first I take an auxiliary series as un equals to 3 to the 5 sorry 3 to the power n by 5 to the power n, and now we find this limit LT n tends to infinity an by un, then this will be LT n tends to infinity, and 1 plus 3 by not 3 by, there will be 1 by 3 to the power n minus 1 by 1 minus 1 by 5 to the power n minus 1. And obviously this is 1, and this is non-zero positive number. So by this uh, if you observe un, then this is nothing but the terms of a geometric series whose common ratio is 3 by 5 and the first term is 9 by 25. So any geometric series with common ratio less than 1 is convergent. Since so this series sigma un is convergent, so by comparison test this series an will also be convergent. So for the first we got the answer. Now we go for the second and see on the other side, and for this we take again an auxiliary series, and for that I take Vn 1 by n square to the power 1 by 4, that is 1 by root n. Okay, you may think that how anyone take the auxiliary series. For that, you if you see the first case which I have solved, here you see inside the enclosure in the numerator there is 3 to the power n plus 3. When you tend n to infinity, then 3 to the power, in comparison to 3 to the power n, 3 is much lesser, so that 3 must be omitted in auxiliary series. So accordingly, you see here in the numerator 3 to the power n, and for the same reason, if you see the denominator here, you think same, then you have this one 5 to the power n. So in the second, I mean for the series sigma bn, we do the same. Here you see in the denominator, you see inside the bracket 1 plus n square. So when n squared, n tends to infinity, then that is a great number in comparison to 1. So I have omitted 1 and I have taken just n square. You see here. Okay, so this is the process, this is the way to choose the auxiliary series. And now in this case as well, if we do lt n tends to infinity bn by vn, then you have n tends to infinity, and here will be 1 by 1 by n square plus 1 to the power 1 by 4, and you know this again will be 1, and which is non-zero positive finite number. Okay, and here also you should add finite. Okay, finite. So in the both, so now since we got a non-zero finite positive number, so by comparison test, nature of these two series, I mean sigma bn and sigma vn, will be the same. And you know sigma vn is a divergent series. This series is divergent. This vn equals to this, you know, and this one is divergent series. You know, all series of such type 1 by n to the power p, where p is less than 1, is divergent. So since sigma vn is divergent, so by comparison test sigma bn will also be divergent. Okay, so divergent. So what we have now, we have the first series sigma an convergent, while the second sigma bn is divergent. And if you see the options, then certainly you will have option C as your correct option. Okay.